Very good afternoon to you all. And thanks to the chairman and Dr. Tripta and other team for inviting me for giving me a lecture today afternoon. Well, I chose this special topic exploring the potential of mathematics. There is a specific reason for that because mathematics is basically used in every topic, whether you are an engineer in any branch or you are a student of physics or mathematics, you need mathematics always. You cannot avoid this mathematics. My profession has always been a teaching and research in mathematics, but my passion is different. Working on women empowerment, for that I have delivered lectures at IIT Guwahati and many other universities abroad also, and inspiring girls for STEM, as well as all other students, making them believe yes, the mathematics is a subject which is applicable to your field day to day as well in technological every time. You can develop your technology, you can develop your profession, you can develop your, you can say, your jobs if you have very good competency in mathematics. It is not concerned whether you are working in IT or you are working in any other field. My simple question is, can we sustain without air or without water or without food? The answer is absolutely no. My question again, next question is, can the community or the society sustain and develop without mathematics? Obviously, I don't know, but my answer is no. That any society cannot sustain and develop. I'm not saying that a society can remain. Remain it can always without mathematics, but if you want to sustain, develop without mathematics, answer is no. Leonardo da Vinci in the 15th century remarked very efficiently, no knowledge can be certain if it is not based upon mathematics. I mean, the great Albert Einstein, we all know, he said imagination is more important than knowledge. Knowledge is limited, but imagination encircles the world. He was a great mathematician. You already know Albert Einstein. He has given, I mean, E is equal to mc square and many other similar formula applicable to physics, applicable to electronics, applicable to electrical, and so many branches, right? He said that knowledge is limited. So what you know, imagination. So that means you have to have the imagination, you have to have the vision of applying mathematics to various fields, and that is unlimited. That is basically I'm just talking about the nature of the mathematics, and I've already explained that it is basically based on the puzzles and the paradoxes, and it is a science of discovery. Many discoveries, maybe in physics or chemistry or biology or science or engineering, right? They were developed on the basis of the mathematics. These discoveries came later, and thus, I mean, the involvement of the mathematical concepts came late. So the development or the use of mathematics was not appeared before the word whenever these you can say discoveries came in. Zoom it never happens because I've got so many presentation given so many presentation on Zoom only. Google Meet is always creates problems. Anyway, please bear with. So these are the various things what the mathematics provides you: social values, moral values, vocational aims, practical use, international aims, development of the scientific attitude, discipline, life, and intellectual development. I'll show you that is how mathematics is basically responsible for your intellectual development. Right? There has been many great mathematicians. I'll not go in much details about this. For example, Euclid. Euclid was a great mathematician whose geometry is well known. Pythagoras theorem we read right from sixth classes. We read Pythagoras theorem, who gave many parabola, ellipse, and their properties, etc. Aryabhatta was great mathematician. People say even, I mean, it was made a comment. It was made by various international scientists that had the Aryabhatta not given so many, you can say, conceptual mathematics to India, the mathematics would not have taken its shape what it has currently. Bhaskaracharya, the great mathematician of India, who has given so many, you can say, simple examples and geometric progressions to, you can say, for the world. He was the S. Ramanujam. Do you know that S. Ramanujam was such a great scientist that Professor Hardy of UK sent the ticket at that time to bring the Ramanujam to UK. He called Ramanujam. Ramanujan was too poor. He doesn't have any money. Then he sent his ticket and called Ramanujam to UK so that whatever knowledge, whatever you can say research he was doing in India may be credited to UK. This is what he did. Let us now see the mathematical myths. Mathematics is always creates fear. Many of the students who are attending this webinar, they know that whenever we talk of studying mathematics, they always are full of fear. They consider mathematics static because nothing moves. Mathematics remains static. Mathematics cannot be compared with other sciences. Mathematics is solitary. That means it is just isolated, and no career can be implemented in mathematics. So, in a nutshell, mathematics is hard, mathematics is boring, it has nothing to do with real life. But what is the truth? Is mathematics is important in any field, in crime detection, in medicine, in finding landmines, and in Disneyland, in sports, in you can say construction, in human life. Mathematics is very, very important. Right? It is embedded in our life, our culture, our growth of the society. Its role is accepted widely. Now you use your mobile daily, telephone, television, internet, computer games, satellite, then weather forecasting, computers, mobile devices, etc., etc. How they are working, they would have nothing would have been possible without, you can say, the use of mathematics. I just show them one by one. You know, information was given about 3 days ago by the Uttarakhand government that 2 or 3 days we will have a heavy rains due to that tornado. But how they found out? They found out only on the basis of the mathematical models. It is really fascinating. Many discoveries in physics were predicted by mathematics before they were observed experimentally. Mathematics provides you everything in logic and, you can say, in principle. In telephone, television, internet, etc., mathematics is very much used. Let's see now what is the goal of education? Is to improve minds, enable the student to acquire abilities and skills to accomplish new things. But what is the aim of mathematics? Ability to reason precisely and analytically about abstract structures with logical decisions. So, in a way, whatever is the a goal of the education, that is all imbibed in the goal of the mathematics. Right? It is nowadays no more abstract science. Its application is become enormous in almost many fields, industrial mathematics, and above all, efficient computers and paradigm of parallel computing has made more facilitating this application of mathematics. The mathematics is basically, its application is based on two things: modeling, which is based on data analysis, and physical process. In physical process, just as any physical process takes place, for example, a car is moving, and you have to find out that is how much distance time the car will take in reaching from Roorkee to, say, RCE. Then you make a mathematical model of it and just give it some initial conditions. You'll find out exact time, that is how much duration the car will reach. Exactly, it happens with aeroplanes. Now, whenever you travel by planes, you know that we will start from Delhi at this time and we will reach New York at this time. How it has been decided? By preparing the mathematical models. Now, if we talk about the engineering, because you are at Roorkee College of Engineering, there are many engineering domains. I divide these engineering branches into two parts: electrical, electronics, computer science, and IT, and civil and chemical and mechanical. Civil and mechanical or chemical I talk of, they are all based on concept of fluid flow and transport phenomena. Civil, you are talking of the flow of the water. In mechanical, whenever you develop any machine, so oil is flowing in that machine, you want to know or enhance the efficiency of that machine. Similar thing is chemical, when heat flow, fluid flow, the mass flow happens. So all they are basically based on the transport phenomena. All of them are governed by the types of the differential equations. Now, if I talk about other mathematical concepts, basically towards the computer science, electrical engineering, electronics engineering, and IT, then if I talk of the matrices, you all know about matrices. It is very much used in image processing, in data structures, in computer graphics. I talk of relations, it is used in discrete mathematics, software engineering. All these 5 topics, they are basically concerned with computer science, electronics engineering, and information technology. So there are many other topics which are basically developed on the basis of the mathematics: bioinformatics, cheminformatics, computational biology, computational physics, computational engineering, computational fluid dynamics, computational mechanics, quantum computing. Now, if you talk of the computer science, Quantum computing is the day of the computing, today's computing, when we want to have a quantum computing very efficiently, right? And all these are the latest development fields based on absolutely the computational mathematics. Now let us see various designs of the, just 1 minute. 1 minute. How the mathematics is used. You just take of the interior design, right? Mathematics is always used here. Suppose you want to develop this, you can say these stairs. So you will have to find out how many stairs you want to develop, so that if they are comfortable also, they are easy to raise, and they are easy to construct. They don't have much, because they don't lose any place, and they are economic also. So how we do it? Oh, please stop sharing. Again, I'll have to go back. Let's stop sharing. Just 1 minute. Yeah. Let's just stop here otherwise. Is it okay? चल रहा है. It's okay. It's okay. Right. Right. If you take the very simple example of gardening, so you will just laugh. What is the role of mathematics in the gardening? No. If we are doing the sowing the new seeds, or seedlings, or planting, then you need to make a row and count them out of even make holes. That is how many voices gone. So you need to know, find out, that is how the plants should be plants should be sown in order to have the more you will say most efficient gardening. You cannot plant everything, any plant any place between leaving a fixed distance. That is what you can say mathematics required. Symmetry in nature, it has a very direct application in the nature. You see so many flowers, sunflower, it is totally symmetrical about this. Just think, if this flower would have been like this, non-symmetrical, you would never have relished this flower. So this is a symmetrical concept of mathematics which is even used in the nature. Just see this, you can say bird, how much symmetrical it is about the middle line. It's all wings, beautiful wings, and you always feel pleasure in viewing these dancing birds. Use of geometry in yoga. Number time today we are putting more pressure in the yoga, but how this particular, you can say, asana is done, then our yogi ji always says, okay, make it so that you are just making a triangle in this sense, or you are just making a curve, a smooth curve, then this is the chakrasana. So there are many, you can say, yoga which are basically explained with the help of the mathematical geometries or mathematical, you can say, figures. Yes, this is a very good example. When we make a phone call, we have to enter the numbers in a certain sequence for the call to be completed. Yes. Have you ever thought that your number is suppose 923651234 5? Can you fill any number? Because these are 10 numbers. So you can just enter these 10 numbers in any sequence. So your call should be matured, but it doesn't happen. The number, all the digits of the number has to be entered in the same sequence. So sequence is a basic concept of the mathematics. It has got very, very important role. So then only the colors your call will mature. So this is another application of the mathematical aspect of sequence to a real life application. Yes, this is a very good example. This is a TV, screen of the TV. Have you ever noticed that the screen of the TV is always like this one, rectangular, but length is more, the height is less. It is never like this. Mobile is like this, but the TV is like this. Have you ever thought? And why it is so? The mathematical concept is behind this. That why the screen of the TV is rectangle with length more, height less, whereas the screen of the mobile is always like this. When the height is more, the length is less. The students of image processing, students of computer vision or computer graphics will very well understand this reason of this one. In sports, every sport contains application of mathematics for success. When we toss in game, there is an equal chance of getting head and tail. But sometimes what happens, we just analyze, that is how many times the tail has, when the tail comes, how many times that particular team has won. So immediately we guess, yes, that particular team has got the tail, so he has got a good chance of winning the match. So these are the things that are made all these analyses are made on the basis of the mathematics. Referees and coaches make calls which are based on time. We can compare failure and success rate by collecting data on the past game rate. These are some of the application of the sports. I can take each of these application in details, but that will take a lot of time. Similarly, you have seen the javelin throw. You know that this tip of the javelin has got a relation between the rest part of the javelin. It's not that the length of the tip can be anything. The peak of the tip can be anything. No, its length and breadth has a particular role, particular relation between the length of the javelin. Similarly, the tracks. All the tracks are always oval. The tracks often, you can say, in any running, it is never circular. It is always elliptical. Why? What is the reason for that? There is a reason for that. That elliptical, whenever you are running, you never lose your balance. Whenever you run on the circular one, circular path, there is every chance that you can lose your balance. Further, the inner track and the outer track, both of them have the same distance. Both are having the same distance for the runners. Whereas in the circular path, it cannot be. There is a symmetry in human made. If you have been to France or Paris, you must have seen this building. It is too high, but it is very much symmetrical about this. Don't talk about the Leaning Tower of Pisa, which is basically the slant, and it has been, it has been calculated mathematically that how much it is inclining, it is tilting every year. Right? This is the biggest Eiffel Tower of Paris, which is symmetrical over the central line. In drawing, whenever many of you must have your own house, so you must have seen that how the geometry plays in making the drawing of your house construction. Whenever you go for the construction, how the this you can say that window has to be constructed. What should be the size of the window? What should be the size of the door? What should be the, you can say, the slope of these roofs, etc. Everything is calculated mathematically. This geometry is a very important part of the mathematics. Number of times we think that does the geometry has no role in music. Geometry has a very important role because all these musical instruments are based on the strings, the wire. Their thickness basically depend upon or affect the, you can say, the vibration of the wire. When I full the screen, I mean the increase in the full size, this is creating a problem. But anyway, so by this example, by this small example, I just wanted to show that this is a group dance between the two birds, and you can just see the absolutely the angles of the hands and the movements of their legs. If they are not proper in the same order, then the this group dance will absolutely be appearing to be tasteless, and you will never enjoy. So whenever you are going to have any dance, group dance and everything, the mathematical movements, the movements in terms of the mathematics has to be very good, very correct, and properly synchronized. This is the how the mathematics is applied in dancing even. Fibonacci number. And you might be knowing a Fibonacci number. Fibonacci number has got a lot of application. I will come back to this one. It is applicable in, you can say, in many flowers. Their patterns are such that their patterns in the first year, second year, third year, the patterns in the third year will be the sum of the patterns in the first and the second year. That is the Fibonacci sequence. I'll just come to this example later on. I just first of all talk to this number 1.618. It is called as the holy and the golden ratio or the holy number or the divine number. Why? This 1.618 ratio has got a lot of application in your body itself. The ideal result, if your the length of the, you can say the length of your face to the width of the face is 1.6, then it is considered to be a beautiful person's face. If the distance between the eyes is 1.6 times the distance between your lips, it is called as the absolute you can say the placement of these eyes and the lips. Similarly, the length of the face over the distance between this distance is 1.6 times that this distance. If it is so, then the face appears to be very impressive. Similarly, the distance between this is 1.6 times the distance this, then it is, the absolutely clear and good one. the length of the mouth over the width of the nose. Length of the mouth over the width of the nose is 1.6 times. If it is so, then we say it is very balanced face. And if it is not, then it is not. Then next one, this is not one. Distance between the tip of the eye, between the distance of the distance between the tip of the eye, this distance, and the distance between the eyeballs, if it is same, we say that this is a balanced one. Distance between the tip of jaw to the nose over the tip of jaw to the lower lip, this distance and this distance. If you take the ratio of this distance, if it is 1 by 1.6, then we say it is totally balanced one. Right? Similarly, so many distances are there. Ratio of this distance to this distance. That is from the tip of the ear to the head to the tip of the ear to your, you can say your jaw. If it is 1.6 times, then we say it is properly placed. Distance between the tip of the jaw, this whole distance and this distance, the ratio is 1.6. It is absolutely good enough. Then that distance between this distance to this distance, length between the two front teeth to the width, if it is 1.618, then you say that your teeth are proper and good, and you can say impressive. Similarly, in this distance, this distance and this one, this length to this one, if it is 1.618, then this basically these two distances are, it prevails the golden rule. Similarly, the distance, this whole distance, and from navel to this distance, if it is 1.6, then your height and your, you can say, is proper. Similarly, this length from and the ratio of this length, and it is 1.6. That means your hand is very good properly. Similarly, there are so many other ratios, right? So I don't think whether you are knowing that this 1.6, the golden ratio, the golden number, has got a very important role in making you beautiful in all directions. This is basically the, you can say, the application of the Fibonacci sequence. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month. So at the end of each second month, a female can produce another pair of rabbits. Then our rabbits never die, and the female always produces only one new pair every month. Then the puzzle is that how many pairs will there be in 1 year? And that solution was solved. It was solved by Fibonacci, and on its solution, it is called as the Fibonacci sequence. Okay, number of pairs first, 1. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. This is how the pair of rabbits increases. This is very important to know. Another application of the Fibonacci sequence is in the very important classified plants which are very costly. And we are interested, that is how many branches this particular plant will have after 2 months. So first month it is this branch, second month this one. So third month we will know the sum of the earlier two will give you the development of the branch in third month. Similarly, development of the branch in fourth month. So that we can know that this costly plant, there are very rare plants. So this is what happens with that. Some more Fibonacci applications in music. Music involves several applications of Fibonacci. A full octave is composed of 18 total music tones, 8 of which make up the actual music octave, and 5 are the remaining ones. Mathematics is crime. Key blurring in number plate. A short crime story. Burglar robs a bank. It escapes in a car. It pursued by police. As usual, the police comes late. But the good news is that police takes a photo, but the photo is blurred. Now, what is the use? So, how to improve that photo so that it is useful? How to make the clarity? Yes, we just develop a model by, you can say, by having certain mathematical applications. This is the original image, blurred image. So we now do the inverse problem, and inverting the formula we can get the blurred, but we need to know the blurring function. This is the blurring function we can use mathematically, and after inverting we got this number. So this number is obtained, and now police can do its own work. Right? This is a very good application through image processing. Those who are doing the image processing, they know how to do all these things. These are the various types of space errors. various types of curve, that is what we can generate. I'll give you some example. The simple example is, suppose I'm in CAD or CAD, computer aided design or computer aided manufacturing. My client says that you just give me, you can say the bonnet of a car, a small car. Now the thing is that what should be the shape of the bonnet of the car? Should it be like Maruti 800 or should be like a Steam or something like this one? So how do I generate it? I can generate it through the help of the synthetic curves, what are called as a Bezier curve. You must have noticed that in the cooling tower, the shape is just like this. How this shape is was for a given diameter and height of a tower and a given strength. The shape requires less cooling than any other curve. And they are too big in size, so their shape and the money, a lot of money is involved in that. In aeroplane, helicopters, you must have seen this type of, you can say, fans. So how do we generate these, you can say, fans? This is what they are generated using the, like this one. They do not follow any specific, you can say, shape. But how they are generated? They are generated using the, what I told you, the Bezier curves. Now, the application, a big application of mathematics is in weather forecasting. These days, it is very, very important, especially in US, Houston, California, where when the weather creates havoc. Even, I mean, just 3 days ago, that weather forecasting was done about that particular, you can say, the regarding the speed of the air and all that, so that people become, you can say, they are already, they are informed that you have to leave this particular place, you have to remain satisfied, and you have to remain cautious, so that this type of thing may not create any havoc. So weather production is a very, very important, where the mathematical model has got very important role. And there is an Isaac Newton Institute of Mathematical Sciences in UK, where such type of problems are solved using the mathematical differential equations. Aerodynamics. Aerodynamics, as I told you, it has got a lot of application, mathematical lot of application, not only construction of the, you can say, blades of the and the fins of the aeroplane, but also to decide what should be the, you can say, the temperature, the size, the you can say the speed of the wind, and during the you can say the corresponding conditions, where when the plane should take sufficient, you can say, cautious. So these are all based on the mathematical models. Aerospace engineering is an engineering discipline with civil engineering and electrical engineering. The minimum mathematics prerequisite to this time, like calculus 1, calculus 2, they are really the source of delight, no doubt. When you sit to the beach, you are very, very happy. When you sit to the beach, you are very happy to see the tsunamis, to the waves. But when they become havoc, just like a few years ago in India, it was like we need to understand how they form and how they forget, and how they, you can say, they can produce the devastation. What is the speed of these waves? What is the height of these waves? Everything can be used, can be determined by solving the partial differential equations. Using mathematical model, prediction of future state of is called as numerical weather prediction, NWP. But one very important thing, that is what I want to tell you, is that numerical weather prediction extends to only 6 days. Insight. Insight means you can find out what is happening inside your body, which is not visible using the computational techniques. Right? This is just like, I mean, if I share it, it will again create a problem. This is how you can visualize what is, I mean, how the breath particles, how the oxygen particles are moving inside your lungs. Then foresight. Foresight means how, if you have to swim, then in what direction you should swim, so that you are facing the minimum pressure on your chest. Sometimes, number of times you listen, whenever you are just listening any commentary during the, you can say, swimming competitions, that that particular person died and collapsed because he experienced such a large amount of pressure on his chest that he could not tolerate and collapsed. So mathematical models gives us that what should be the angle of jumping, so that he experiences the minimum amount of pressure. Similarly, this is just a, I mean, type of mixer. We have constructed it in our mechanical department along with mathematical model. So this mixture, can do every type of work, and the blades are in such a way that is efficient as well as economically very, you can say, simple. There are many applications of nowadays nanofluids also. This is again another mathematical, you can say, concept. Have you ever thought in your car earlier what was the coolant? It was simply distilled water. But nowadays, what is the coolant? Coolants are the nanofluids. What are the role of the nanofluids? Mathematically, it has improved that these nanofluids help to drive the car at a longer distance without being the radiator hot. Similarly, that is, it has application in the domestic refrigerator, in even computers. Now, 50 computers you can keep in a system in an area, and you don't need any AC for that, because the chips are constructed in such a way that their cooling is very, very efficient. Right? So now, if I come to the end, do I need a lot of mathematics? No. A high level of mathematics will make you a better scientist, no doubt, but it doesn't mean that you need high mathematics for application. Only thing is that your visualization, your thinking, how you can use your mathematical knowledge for an engineering domain, for your physics, for your chemistry, and all that. All of you must be knowing that half of the physics and most of the chemistry is already based on mathematics. So the thing is that the need is of visualization of the things. What is the reward of doing mathematics? Problem solving skills that will help in every aspect of your life. Good organizational skills. When you organize anything, now today when you must be organizing. Okay, जब morning में इतना काम करना है, after this करना है, then by 3 p.m. I have to be free to listen this webinar. So your organizational skills improve with the application of the mathematics. You have a logical and clearer thinking when you use this. Mathematically, when you want to prove something, you are very clear in your mind. Yes, it will happen today. You cannot talk in a very absurd language or it is not sure. Okay, it may not be. ये mathematics में may or may not be नहीं होता. You are very logical, clear, sound, very interesting and satisfying life full of challenging achievements. That is what you get from mathematics. Nowadays, I will just talk only for 2 minutes about the computational thinking. Sometimes if I get time, then I will talk on the computational thinking. It is now one of the latest area which is basically being generated. As the name indicates, computational thinking, does it based on the computers? No, it is based on the mathematics. It makes the human being to realize what cannot be done alone for solving problems, for designing systems, for understanding and implementing the power and the limits of human and the machine intelligence. This computation, you can just open the Google now and you will find and type computational thinking. You will see that each day you are getting something or else on the computational thinking. This computational thinking is taught, is implemented to a child of age 3 till you are in your profession. Not only in profession, but day-to-day life. तो इवन एक 3 साल का बच्चा भी कंप्यूटेशनल थिंकिंग को यूज कर रहा है. So this is now slowly being implemented in India also. I will just go in detail sometime. Sometimes you can say in future, if I get to speak on this computation. Now, if I revisit my mathematical myths, with mathematics earlier was fear, now it is joyous. Mathematics was static, now it is dynamic. Mathematics is at the back of other sciences, it is now at the front of other sciences, in the frontier of other sciences, because every field requires mathematics. आप सिविल इंजीनियर, आप इलेक्ट्रॉनिक्स इंजीनियरिंग में हैं, लेकिन इफ यू डोंट नो द प्रॉपर यूज ऑफ मैथमेटिक्स, इतनी सारी आपकी सीक्वेंस हैं, सीरीज हैं, दे आर ऑल यूज फॉर इलेक्ट्रिकल इंजीनियरिंग, फॉर इलेक्ट्रॉनिक इंजीनियरिंग, कंप्यूटर नेटवर्किंग यू आर यूजिंग इन द कंप्यूटर साइंस. So full, you can say, mathematical implementation is there. Mathematics is not isolated, it is collaborative. Using the mathematical concepts, you can improve, you can update your working in other fields. It is basically the foundation of all quality careers. So now, after revisiting the mathematical myths, I am very, very happy, I can say. What is the aims of teaching and learning mathematics? Yes, enjoy mathematics and develop patience and persistence while solving your problems. Never lose your patience. नहीं भाई ये problem नहीं, छोड़ो इसे दूसरी करते हैं. No, never lose your problem. Patience. Once you don't lose your patience in working with mathematics, same thing you can apply in your life also. In your life, so many problems are approaching to you, attacking you, If you have a habit of developing patience, you will have in your life also. Becoming confident in using mathematics to analyze and solve problems both in school and real life situations. Develop the knowledge, skill, and attitudes. Attitude is very, very important, necessary to pursue further studies in mathematics. Develop mathematical curiosity and use reasoning when solving the problem. Yes, don't think that okay, whenever I'm solving a problem, I have to use only this formula. No, maybe that you are another Albert Einstein. You may be Albert Einstein. You know, Albert Einstein has not been ज़्यादा पढ़ा लिखा नहीं था. He was very much less studied in his schools, but he is known for his, you can say, knowledge and for his discoveries. So why not we be Albert Einstein also? It is only depends upon that is how much curious you are, how much curious you are. So that is the very very important thing. That is what the mathematics teaches you. I'll now come to you finally in the end of my presentation, the beauty of mathematics. A very interesting way to see what basically mathematics gives you. If A, B, C, D, E, F, G, H up to Z is a percentage as 1 to 26, that is A means 1, B means 2, C means 3, D means 4, and so on. So hard work will mean HARDWORK will mean 98%, and knowledge KNOWLEDGA will mean 96%. But I want to give 100%. So what is that which gives you 100%? Let us see. It is the attitude. Attitude gives you 100%. What do we mean by attitude? As I told you earlier also, attitude means lagan. Once you start anything, you will not leave it until unless it is finished. This is the, you can say, your nature, this is your culture, this is your thought process. Once it is introduced, means you will leave, you will implement this not only in your study, but in your life also. जो करना है वो करना ही है. You cannot leave it. So attitude is very very important, which basically is teaching is taught by the mathematics. And mathematically we have proved that attitude gives you